Hey friends, welcome to our series of one-dimensional DP must-do problem set. The first problem is find maximum sum subarray from a given array. For example, our array is this. The first solution which comes to our mind is of finding all the subarrays, computing sums and then comparing the sums. But this solution takes more time. It is inefficient solution because the O of n square time is required to compute all the subarrays, and for each subarray we require O of n time to compute sum. So we have to discard our first approach. The second approach for our problem is by using prefix sum array. We have used prefix sum array to decrease the time complexity of finding summation of individual subarray. For example, if we have to find summation of a array which is starting at ith position and ending at jth position. To find sum of this subarray, firstly we have to prepare our prefix sum array. To find sum, we can do it in O of one time by using prefix sum array. But this was not the case in previous approach because it was taking n time to compute summation. Here, to find sum of an array which is starting at ith position and ending at jth position, we have to simply subtract I minus 1 position from jth position. The intuition behind this is the sum till jth index is this much, and as we know we have to find sum from this index to this index. Here we have to subtract our this much part. This gives this much part. This is the intuition behind using this statement. But still, in this approach, it takes O of n square time to compute all the subarrays and comparing the sums. So we have to again discard this approach. The last, most optimized approach for our question is, firstly we have to declare two variables, answer and sum, and initialize them to 0. Now we have to iterate our array from first position till nth position. Now add first element to our sum, that is 5. On adding 5, our sum becomes 5. Now compare if sum is greater than answer or not. If sum is greater than answer, make answer equals to sum. Now add next element. On adding minus 6 to our sum becomes minus 1. Now here is the catch of the question. Suppose if our sum is equals to minus 2 and the element which is next is 20. On adding minus 2 to 20, our sum becomes 18. But if we did not add minus 2, our sum will remain 20. As we see that 20 is greater than 18, so when we do not add the negative numbers, the sum is greater. So whenever our sum is less than 0, we have to make it equals to 0. On adding next element, our sum will become 2. Is sum greater than answer? No, answer will remain as it is. Now move to next element. On adding minus 1 to sum becomes 1. As sum is greater than 0, it is not needed to make it 0 again. Is sum greater than answer? No. Let's make it same. Add next element. On adding next element, our sum becomes 6. Is sum greater than answer? Yes. We will make answer equals to sum. Adding next element. On adding minus 10, our sum become minus 4. But here is the same condition. Now we have to again make our sum equals to 0. Is sum greater than answer? No. Add next element. On adding 3, our sum becomes 3. Is sum greater than answer? No. Let's make answer equals to 6. This is our final answer. To iterate over this array, we require O of n time. So this is most optimized solution of this problem. One precondition which we require to check is that if all the elements which are present in the array are negative, then we have to print the element which is maximum. Suppose that if our array is of 4 elements and the elements are minus 1, minus 2, minus 10, minus 5. Here the maximum sum subarray is of only one element. So one precondition that if all the elements are negative, then we have to print the element which is maximum. Thank you. Like, share and subscribe my channel.